with translations and transformations, these are some of the things that you need to be aware of. So again, if you've got an ordered pair, if it was translated 3 units in the positive direction of the x-axis, we know that means moving to the right. So again, here's your ordered pair. You've got your x and y coordinates. 3 units in the positive direction of the x-axis means you're adding on 3 to the x-coordinate, which can be written as follows. Again, that's a translation or a transformation of the plane. It's the terminology that's used there. It says each point in the plane is mapped to a unique second point. It says furthermore, every point in a plane is an image of another point under this translation. And we'll use this word image a fair amount. So again, considering the notation, if you have a scenario where you are translating 2 units in the positive direction of the x-axis, that is to the right, but also 4 units in the positive direction of the y-axis, that's up, it can be described by this rule. So you've got your x and y ordered pair, and that's going to map to x plus 2, so translation of 2 units to the right, and it's going to be translating 4 units up also. So as I just said, it reads the ordered pair x and y maps to x plus 2, y plus 4. What that actually means is if you had a coordinate, let's say you had a coordinate 3, 2, x value 3, y value of 2, when you are mapping it, you obviously add 2 onto the x value here, and you're going to add 4 onto the y value to get your new translated point. Again, it says in applying this translation, it's useful to think of every point as x and y in the plane as being mapped to a new point. Now the new points that they're referring to are x dashed and y dashed. It says this point x, y is the only point which maps to x dashed, y dashed, and this can be written for the translation. So again, here where we've had what it maps to, x plus 2 is the x, the new x value, and the new y value is y plus 4. Here's how you can write it. The x dashed is x plus 2, and the new point y dashed is going to be equal to y plus 4. So that's sort of the terminology that's being used there. Alright, let's jump over to exercise 3D, which obviously hopefully you've done most of these things leading up, and we'll look at things like dilations and translations and those types of things. Exercise 3D is really putting it all together and doing the combination of all of these things. Alrighty, so exercise 3D, let's track it down. Cool, so today, combination of transformations. As I've alluded to, hopefully over the holidays you've looked at other types of transformations, such as dilations, reflections, and translations. So here are some of the things that you could be considered or should consider. A few different combinations could happen together. So if you had, for example, a dilation of factor 2 from the x-axis, that means we're going to be multiplying the y value by 2. This is how we would obviously map that there. Y, we are dilating by a factor of 2 from the x-axis. The y coordinate gets multiplied by 2. That's the first thing that's done. If another combination's happened from there after that one, it's followed by a reflection in the x-axis. Reflection in the x-axis means obviously we're going to be getting the negative value of the y coordinate. We're going from here, taking the negative value of that, it becomes negative 2 y. Again, if you have that and you've got some coordinates, let's say you had the coordinate 1, 1, showing how that those two combinations are translated or transformed. Obviously nothing's happening to this x value, but the first step was the y value was multiplied by 2, which we can see happens there, and then from there the next transformation was it was reflected in the x-axis. That becomes negative. Obviously there's another example here. Dilation of factor of 2 from the x-axis, same difference again. The y coordinate gets multiplied by 2, followed by a translation of 2 units in a positive direction of the x-axis. So obviously that means we're moving to the right, which means we're adding on 2 to the x coordinate, which we can see is being done in this step. But not only that, it was being 3 units in the negative direction of the y-axis means we need to subtract 3 from that y-coordinate, which is what's happening here. And again, you can apply the same process for the coordinates 1, 1 to find out whereabouts we end up with that. Alright, worked example number 5. Alrighty, cool, this is a cool one. It says here, find the equation of the image of y equals the square root of x under the following scenario. So the first one's saying what happens if we have a dilation of factor 2 from the x-axis followed by a reflection in the x-axis. Alright, so here is what you need to do. We've got the x and y coordinates. The first translation was a dilation factor of 2 from the x-axis. Means that's going to map to multiplying the y coordinate by 2. Dilation factor of 2 from the x-axis multiplies this by 2. Following that, there was a reflection in the x-axis. Reflection in the x-axis means we're going to take the negative of the y coordinate. So this gets multiplied by a negative, which ends up here. So most people should be fairly happy doing that. The next part is as follows. It says if x comma y maps to x dashed y dashed, then what we need to do is actually write out what each of these is going to change to. So we've got x dashed is still going to be x. Nothing happens from here to this point. They stay the same. So the new value of x is just going to be the same value as what it originally was back here. New value of y is this here. It's going to be negative 2y. That's where that comes from. That goes from there. Cool. So hopefully people understand that. From here, we need to rearrange these new values so that they are in terms of the original values. So here, obviously, x dashed is equal to x. We want it so it's x. The original value is equal to whatever. This one's easy enough to rearrange. It just becomes that. Here, we've got y dashed is equal to negative 2y. We would want to rearrange it so we can say y is equal to whatever. So having that, we do need to move things around. We need to get rid of this negative 2 here. To get rid of it, obviously we need to divide this side by negative 2. We need to divide this side by negative 2. We end up with y is equal to y dashed divided by negative 2. Once you have these things rearranged, to find the image, in this particular case the image of y equals square root of x, where you've got the y and where you've got the x in this equation, you're going to substitute in what these new values are. So here y is now y dashed over negative 2, so we've substituted that in. And here where x is, we're going to substitute in what it is. X is equal to x dashed. Cool. Some people are tempted to leave it like that, but what we want to do is rearrange it so it's in a nice format where it's y dashed is equal to something rather than having all this stuff here. So again, it's just a matter of rearranging things. So to get rid of this dividing by negative 2, obviously we need to multiply both sides by negative 2. You end up with y dashed is equal to negative 2 square root of x dashed. Cool. Now once you've got that rearranged nicely, you can get rid of these little dashes here to write out the new equation nice and neatly. So again, once you've done, this is just notation that's used to get to the new equation. So the equation here can be written as just y is equal to negative 2 square root of x. Next one, similar types of things, except there's a little bit more going on. There's a dilation factor of 2 from the x-axis, which was the same as what we had before. Cool. So we need to multiply this y value by 2. And then it says there's a translation of 2 units in a positive direction of x. So we need to add 2 to the x coordinate, which we've done there. And also there's 3 units translated in the negative direction of the y-axis. So again, that means we're going to be taking away 3 from there. So again, it's a matter of just breaking it down to show what is going on. It says again, mapping x and y coordinates to their new x and y coordinates using the notation x dashed and y dashed. Obviously the new value of x is going to be equal to x plus 2, which we worked out over here. The new value of y dashed is going to be 2y take away 3. Happy days there. So once you've got that, remember the next step is to rearrange things so that they are in terms of just their original values, so x and y, not obviously x dashed and y dashed. So first, rearranging this one here, we need to move this 2 across the other side. You end up with x is equal to x dash take away 2, and here we want this y by itself, so y is equal to something. Rearranging, you'd have to move the 3 over to this side by adding 3 and then dividing this side by 2. So y is equal to y dashed plus 3 over 2. Cool. From there, it's a matter of substituting these into y equals the square root of x, so that we can find out what the image is. So here where the y is, we know y is equal to this, substitute it in, and x we've worked out is x dash take away 2, which is substituted in. Again, from here, as I said, some people attempted just to leave it like that. No, we want to rearrange things and so that it's y dash by itself. You have to move this 2 over here, you have to move this 3 over there. So multiplying by 2, take away the 3, and it ends up like this. Now, again, to write out the equation neatly for the image, you don't need to have the dashes in the notation or in the equation here. So you can just write it out nicely. Y is equal to 2 square root of x take away 2, and then take away 3 from that. Alrighty, worked example number 6. Oh, cool, some sketching. It says here, sketch the image of the graph shown under the following sequences of transformations. So they're saying, hey, we've got a graph. First thing that's going to take place is a reflection in the x-axis. Then we're going to do a dilation of factor 3 from the x-axis, which we've spoken about in the previous example, how to do that using that terminology from the x-axis. And a translation of 2 units in the positive direction of the x-axis and 1 unit in the positive direction of the y-axis. Now you could write out each of these things using the notation that we had from the previous example. Yep. Or you can just sort of keep it in your brain, sort of think about it logically with what's happening. So here's our graph here. The first one is to reflect it in the x-axis. So again, here is our x-axis. We know that that's going to change the y coordinates. It's going to multiply by negative. Yep. So here, consider this key point here. The y value is negative 3. Oh, no, sorry, negative 1/3. When you have a reflection in the x-axis, obviously here is the x-axis. It's going to go up over here. This coordinate changes, obviously multiplying by negative, it becomes positive 1/3. Yep, it goes up there. Here, obviously at the origin at 0, 0, obviously the negative value of that's just still going to be 0, so it's still going to be the same spot there. Here is another key feature. There looks like some type of asymptote here at 1. Again, sorry, the y coordinate is 1, so 0, 1. Negative value of that here is going to move it down to negative 1. Yep, so we're doing that translation first. So you can sketch that using those key points. Next, a dilation factor of 3 from the x-axis. What we know here is a dilation factor of 3 from the x-axis is multiplying the y coordinate by 3. So here, if we've done this translation, the first one, and we're multiplying the y coordinate by 3, 1/3 multiplied by 3, that would become 1. Obviously here, the y coordinate 0 multiplied by 3 is still going to be 0. Here, the y coordinate of the asymptote is obviously it's a 0 and negative 1. Multiplying that by 3, it becomes negative 3. So we've done that translation. Last one from here is we're going to have translating in a positive direction, 2 units in the positive direction of the x-axis. So that means it's going to move to the right by 2, and also it's going to move 1 unit in the positive direction of the y-axis. So essentially you'll need to be adding 2 onto the x coordinates and adding on 1 to the y coordinates. So again, here you can see at 0, 0, adding on 2 to the x coordinate, that becomes 2, adding on 1 to the y coordinates becomes 1. Same difference here, adding on 2, adding on 1. Don't forget here, obviously the asymptote, that's at 0 and -3. Adding on 1 to the y coordinate, the -3, becomes -2. Cool. That's part 1 done. Good.